Good morning, everyone, or afternoon or evening, as the case may be. So in the previous videos, we've talked about how to write and balance chemical reactions. Now we're going to start to talk about the types, or how we can classify chemical reactions based upon various categories. In the next few videos, we're going to focus on these 4 categories with one subset category here. In this video, we're going to introduce this first category to the left called precipitation reactions. So you will also find out that precipitation reactions are a kind of double displacement reaction, where in that kind of reaction you have 2 ionic compounds. Let's call them AB and CD. And in these 2 ionic compounds, the cation from one species pairs with the anion of the other species. That's the definition of a double displacement reaction. We will talk more about that and more about single replacement reactions later in this chapter. But what you should know now is that precipitation reactions, which is what we're going to focus on for the next 2 or 3 videos, precipitation reactions are a kind of double displacement reaction, and in that precipitation double displacement reaction, one of the products that is formed is a solid. That solid is called the precipitate. So precipitation reactions, they're double displacement reactions. They form a solid or a precipitate as one of their products. So if that's the definition of a precipitation reaction, the formation of a solid, we need to know how we can predict, given the 2 reactants of a double displacement reaction, we need to not only know how to predict the products, but know if something is soluble or not, if it is a solid or if it is aqueous. So we need to know something about the solubility of a compound. And so we talked about solubility in the solutions lab. We're going to revisit some of those terms here. So when we say that a compound is soluble, that just means that it dissolves in a particular liquid. And when that compound dissolves in a particular liquid, it forms a solution. And if the liquid that does the dissolving is water, then we say it's an aqueous solution. Chemists love to work with aqueous solutions because water is pretty ubiquitous in the lab to use as a solvent. All of the solutions that we will be dealing with in this course will be aqueous solutions. So in this first picture and cartoon, you have an example of sodium chloride, the solute, put into the solvent of water. And as everyone knows, and from the solutions lab, you found out that sodium chloride dissolves in water to give you an aqueous solution. So if something is soluble, that means it dissolves in that liquid. If that dissolving liquid is water, and that compound is soluble, we would say that the sodium chloride or that compound of interest is aqueous, and we would give it the state AQ. If something is insoluble or does not dissolve in liquid, in water, then we say that it is insoluble, and the state that species is given is S. S is not for soluble, S is for solid. So in this picture right here of this reaction, we have potassium iodide that is aqueous. That means it's dissolved in water. The potassium iodide is dissolved in water. It's reacting with aqueous lead 2 nitrate, which is also aqueous. And when those 2 aqueous solutions react, we get this beautiful sunny yellow lead 2 iodide solid. Since it is insoluble, it is a solid, and we give the state S. So we used to actually do this experiment in Intro Chem Lab. I thought it was a pretty cool experiment, but we stopped doing it because you could probably imagine that We have waste disposal problems, specifically because of the lead to iodide. The lead is toxic. So very pretty, beautiful experiment to watch, but not so pretty to clean up after. You should realize, or you should understand, that compounds that are insoluble have the state S for solid. If a compound is soluble, then we say that it is aqueous, or AQ. So before we go to the next slide, let's take a little look at this cartoon. Even though it's a cartoon, it's instructive to show you what happens when a compound is soluble. So we said that sodium chloride is soluble, so it dissolves in water. So when it dissolves, what do you see with the sodium and the chloride ions? Are they still stuck together? They're not. They are separated. They have dissolved into their component cations and anions. And so that's what ionic compounds do when they dissolve in water, when they are aqueous. They dissociate into their component cations and anions. So a solution of sodium chloride does not contain intact sodium chloride molecules. It contains sodium ions and chloride ions. Okay? That fact is going to become important when we start talking about ionic equations with regards to precipitation reactions. For right now, know that ionic compounds, when they are aqueous, when they are soluble, when they dissolve in water, they dissociate into their component ions. And solutions that do that have aqueous ions in them, those are called strong electrolytes. And they're called strong electrolytes because those solutions conduct electricity. If I was to take a solution of sodium chloride and hook it up to a battery that was strong enough, I'd be able to see the conduction or the flow of charge due to the presence of these charged species. Whereas pure water is not a strong electrolyte, does not conduct electricity because there are no ions present. So, ionic compounds that are soluble dissolve into their ions, constituent ions. They produce solutions that are strong electrolytes. So, ionic compounds are an important category of electrolytes, specifically strong electrolytes. The other two categories of strong electrolytes are ones that we will revisit when talking about acid-base reactions. Two other categories of electrolytes, of strong electrolytes, are called strong acids and strong bases. Now, we've already talked about acids when naming acids in Chapter 5, so you should be able to look at this list of species and realize that they are acids because of the hydrogen at the beginning. Some of these acids are binary, some of them are oxyacids, but these list of strong acids that are shown here, these are acids that are strong electrolytes. And for purposes of this course, that means that when I have HCl or HBr or any of these dissolved in water, they completely break apart into their cations and anions. Similarly, there are compounds called strong bases. Now, why these are called bases, we'll talk about later, but you should know that if you encounter one of these molecules in a reaction in the presence of water, that these compounds will break apart into their constituent cations and anions. And with these strong bases, the anion in that species is the hydroxide anion. So, for example, a solution of lithium hydroxide would have lithium ions swimming around and hydroxide ions swimming around. Okay. So, ionic compounds that are soluble, strong acids, the ones listed here, and strong bases, the ones listed here, these are all examples of strong electrolytes. If you encounter one of these in a chemical reaction, you should know that it will dissociate or break apart into its component ions. Anything else, so for example, molecular compounds like sugar, weak acids, or weak bases, these are non-electrolytes. They do not conduct electricity. Purposes of this course focus on the strong electrolytes. So, as we said that ions, or we said that compounds that are soluble, that are ionic, break apart into their constituent cations and anions. What if I have a compound like silver nitrate, excuse me, that is soluble? If I have a solution of a salt with a polyatomic ion, for example, silver nitrate is soluble. When I dissolve that silver nitrate, the cation and anion will still dissociate, but realize that the anions, they're groupies, remember, they like to stay together. So polyatomic ions, when present in a compound that is soluble, those will dissolve as intact units, kind of like the OH from the previous strong base example. So for example, silver nitrate, which is soluble, that would dissolve in water and give you silver ions and nitrate anions. Okay? So polyatomic ions, they dissolve as intact units. They do not break apart into, like for this example, the nitrate would not break apart into its nitrogen and oxygen components. The polyatomic ions dissolve as intact units. Finally, if you have an ionic compound that is insoluble, that stays as a solid, then those ions stay together. So for example, silver chloride, that is a solid that is insoluble. So when it's added to water, those ions stay together. So its state would be S for solid. Both of these, the sodium chloride and the silver nitrate, would be aqueous. So I think this is a good summary of what happens with particular ionic compounds when you put them in water. In the next video, we're going to start here, and then we're going to talk about how to use the solubility rules, something that you do not need to memorize. You don't need to memorize the solubility rules because you'll have them when doing quizzes and exams, but how to use those solubility rules to determine if a compound is soluble or not.